Math 111 students, we're ready to jump into quiz 2. It's your quiz review video. I'm going to go super fast. You can put me on 0.75 speed, or if I'm going too slow for you, you can speed me up to 1.25. You can stop me. You can rewind me. You can use me while you yourself are taking your practice quiz. So lots of options there. All right, so let's hop into it super quick. On your mark, get set, go. Y equals 5 sine pi x. What is the amplitude? The amplitude is 5. And remember, our formula for the period is t equals 2 pi divided by your omega. And our omega is in front of the x, the coefficient of the x, it's pi. So we're going to have, let me just switch it over here right quick so you can see these formulas I've written down. I suggest you, when you start your test, write out your 3 formulas quick. We're here at period. It'll be 2 pi divided by the omega, which is the coefficient of the x. Our omega is pi, so we're going to have 2 pi over pi, which results in a period of 2. 5 cosine x. I'm going to click here, enlarge my graph, and then after I graph it, use the graph to decide the domain and the range. I only have an amplitude change here. My amplitude here is going to be 5. I was doing cosine. Here's your cosine tool. Click anywhere. That's your basic cosine, but I have to switch my amplitude here to 5. And that should do all I need. That's correct now. Phase shift, period, none of that changed. And now I can answer my domain and my range. Your domain in interval notation is, your domain here is all real numbers. You can see how it goes on along the x from negative infinity to positive infinity. But our amplitude changed our range. So now we're going down to -5 on the y and up to +5. In the interval notation, we include -5 and +5. So we don't use the parentheses, we use the brackets here. Number 3, 3 sine x minus 1. So I both am changing my amplitude by a factor of 3. And then I'm going to vertically shift it down 1. So this is 3 sine x minus 1. I'll choose my sine tool, click anywhere. Amplitude, I am changing to 3, and I have a vertical shift down 1. I'm going to save that. And again, my domain for sine and cosine here is just all real numbers. So negative infinity. Oops. Come on. Negative infinity, comma, infinity. And then the range, you can look at here, we go down to -4 and up to +2, including both of those. So we use brackets, down to -4, up to +2, including -4 and +2. So we use brackets there. A tangent x. Which one of these is going to be the graph of the tangent of x? All right, well, I'm going to look over here at, I've got a PowerPoint video here. Let me see if I can, here it is right here. Share this. All right, if you remember back in the day, that's cotangent. Let's go up here to tangent. Where is tangent? Here's tangent. Okay, back in the day when we did our tangent function in section 5.7, if you wanted to pull up the slides under content from 5.7, you can see these pictures of what we did. And so our tangent goes up, left to right, and the normal asymptotes are at every other pi over 2. You have your asymptotes at the odd integers of pi over 2. So pi over 2, not at 2 pi over 2, then again at 3 pi over 2, not at 4 pi over 2, but again at 5 pi over 2. Those are your asymptotes, so those are not in the domain. Those are the numbers that we have to kick out of the domain. All right, so with that thought in mind, let's go back to this guy. All right, so we want to be going up, left to right, and we're going to stretch it by a factor of 8. So 0, this would be negative pi over 2, and that would be positive pi over 2. So I think this one is the one I want, letter A. Let's just make sure, not letter B, that's going down left to right. Letter C changed the period. See how letter C now has asymptotes at every pi or every other pi, but we didn't change the period. And there's nothing here. We don't have an omega. We're not changing our period here. And then letter D is going down. So it has to be by process of elimination, letter A. All right, and so then if we look again at letter A, you can see that your asymptotes are still at the same odd multiples of pi over 2. Odd multiples of pi over 2. So how do we say that? The set of all x such that k pi over 2, x can't equal that. X can't equal pi over 2 and 3 pi over 2 with the k being the odd integer. All right. Then what about the range? We'll look at this guy one more time. What's our range here? Well, we're going to from negative infinity all the way up to positive infinity on the y. So our range is all real numbers. How do we show that in interval notation? That's negative infinity. Oops, not negative 8. I always want to do that. Negative infinity, comma, infinity. And let's close that parentheses. All right, next. 8 cosecant x. Well, it might benefit you to go back here and review the cosecant function. So let's go look at that real quick. Go back here. All right, cosecant. Cosecant is the inverse of the, or the reciprocal of the sine. And so if you look here, your cosecants are going to have their asymptotes every pi. So you have an asymptote at 0, then at pi, then at 2 pi, at negative pi, negative 2 pi. And between 0 and pi, you're going up. So those can be some helps to us as we look on our graph. All right, we're going up between 0 and pi. We are not changing our period. So we're going to have an asymptote again every pi. This one doesn't. This one has an asymptote every 2 pi. We want an asymptote every pi. Nope, asymptote every 2 pi. I want an asymptote every pi. 0 pi. Yep, this one has an asymptote every pi. And between 0 and pi, it's going up. So this one is the one I want. Right here, letter C. All right, so think about it again. Our domain is that every pi, we have an asymptote. So our domain then is going to be k, let's see, x, such that x does not equal multiples of pi, where k is an integer. So every multiple of pi, not every other, every multiple of pi, you're going to have a asymptote. Domain here is one we've got to think about a little bit more. All right, wait a second. Is that the right one? Which one? Yeah, it was C. All right, look at your domain here. 8 is our magic number here. We start at 8 and we go up to positive infinity on the y. And then we start at negative 8 and go to negative infinity. But the better way to think about that is from negative infinity up to negative 8. And then again, starting at 8 up to positive infinity. How do you put that in? All right, we are going from parentheses, negative infinity up to negative 8, and we include negative 8. So we're going to put the bracket there, and we're going to do that. Oh, I'm sorry, folks. Ooh. All right. Here was the right video, excuse me, graph, because this one had your asymptotes every pi. And it was in the right shape where between 0 and pi, you're going up, and between negative pi and 0, you were going down. So I'm letter C here for mine. Here is my domain, set of all x, such that x does not equal k pi, k is an integer. And one more time, looking at this guy, your range, you're going from 8 to positive infinity and from negative 8 to negative infinity. So negative 8 to negative infinity to negative 8, and then we're going to put union with bracket positive 8 to positive infinity. Parentheses on the infinity end, a bracket on the sides with the negative 8 and 8, because those are included in it. Number 7. All right, we've got a period change. This is my t value. No, excuse me, this is my omega value. And now we got to think about what is the normal period of the cotangent, because that's, I'm going to take that normal period and I'm going to divide it by the omega value. So we're working with cotangent here. So let me go back to my PowerPoint slides and hopefully I'll remember to switch back over to the quiz this time. Cotangent function. Your traditional cotangent function repeats every pi, not every 2 pi, every pi. So our period is going to be the normal period of pi divided by the omega. Okay, normal period of pi divided by the omega. So we have pi divided by 1/8. That will be 8 pi. So we have a period of 8 pi. And we're going to pick it up and move it up 3 units. Now, if you remember, just when we were just back looking at that traditional cotangent, just the basic cotangent function, it goes down left to right, down left to right. So we want this guy, it's going to be going down left to right, not A, not C. So it could be B. Let's see if this one has a period of 8 pi. Yeah. However, we should be starting at 0, and then our next asymptote is 8 pi, and then our next asymptote is 16 pi. So that's not this one. It's not B. Let's look at D. Going down left to right, going down left to right, and your first asymptote's at 0, and then 8 pi, and then 16 pi. So this is the one we want. And also see how this one is moved up. Let's see how much we were moving up. We were moving up 3 units. So this must be 3 units here. Yeah, it is. 3, 6, 9, 12. So we've picked ours up and moved it up 3 units. So ours is letter D in this case. What was your period? Your period was every, the way your domain, your domain, we ended up with an asymptote every 8 pi. So letter A, x, such that x does not equal 8k pi, where k is an integer. Every 8 pi, we're going to have an asymptote. And then if you look at it real quick, you can tell your domain is all real numbers. So negative infinity to infinity. All right, Tay. 5 sine 3x minus pi. All right, so just real quick, let's review here all of our formulas. So I've got mine is y equals 5. So 5 is my amplitude. 5 sine 3x minus pi. Okay, these are my formulas for sine and cosine, the amplitude, the period, and the phase shift. My amplitude then is a 5. My period, my t, is going to be 2 pi divided by the omega, which is 3. So 2/3 pi will be my new period. And then my phase shift is going to be, this is our phi. So 3x minus whatever the value is you're adding or subtracting here in the parentheses is your phi. So I'm going to take my phi and divide it by my omega. So my phase shift here, which is how much you're picking it up and moving it over left or right, my phase shift is going to be pi divided by 3. Pi divided by 3. All right, so you can pause me, figure out yours. For mine, I'm doing a sine function, so I need to graph this guy. Let's see. Oh, actually, first I need to do the amplitude. My amplitude was 5. My period here was 2 pi over 3. And my phase shift then was pi over 3. And here, graphing this guy, it was a sine function. Click anywhere. My amplitude was 5. My period was 2 pi divided by 3. My phase shift was pi divided by 3. I did not reflect it, didn't have any negatives to reflect it over either the x or the y axis. All right, write the equation of a sine function with the amplitude 3, so 3 sine. My period is 8 pi, and my phase shift is 1/7. All right, so let's think about that for a minute. I'm going to go back over here to my sheet here, my scratch work. All right, so it says that I am given the period, which is your t, of 8 pi. Okay. Now remember that 8 pi, or your t, is going to equal 2 pi divided by your omega. And that's what we need to figure out. We need to figure out the omega so we can make the formula. Just use your old cross multiplication strategy from 3rd grade or whatever. 2 equal fractions, you can multiply across. This is 8 pi times omega equals 2 pi times 1. Let's solve for the omega by dividing both sides by 8 pi. So my omega is going to equal, the pi's cancel out, 2 over 8 reduces to 1 over 4. So my omega value was 1/4. Now I need to find my phase shift value, which is phi. And remember, phi is going to equal, let's see, actually my, let's think about it differently. Your phase shift is going to equal phi divided by your omega. Okay, well, I was told what my phase shift was. My phase shift was 1/7. I don't know the phi, but I do know my omega. My omega is 1/4. Okay, so I basically have phi divided by 1/4, which is 4 phi. Or let's say that even that's too hard to think about, just cross multiply. So 1 times 1/4 is 1/4, and that's going to equal 7 times phi. Divide both sides by 7. Divided by 7. All right, so that's 1/4 times 1/7, which would be 1/28. You have a phi of 1/28. All right, so let's put this back in here. So I've got 3 sine. My omega, which is what you're going to put in front of your x value, is 1/4. And then I'm going to subtract off my phi value, which was 1/28. Find the exact value of the inverse sine of negative root 2 over 2. All right, I'm going to go back over here, but now I am going to use my cheat sheet. We are interested in the inverse sine of negative root 2 over 2. Inverse sine of negative root 2 over 2. So let's come over. Remember that inverse sine has to be in between negative root pi over 2, excuse me, negative pi over 2 and positive pi over 2. So the inverse sine and the inverse tangent are in this region. Inverse cosine is in this region. But we're right now doing the inverse sine, we need to be in this region, and we had a sine of negative root 2 over 2. So I'm going to go down here, and I'm going to find my sine of negative root 2 over 2. I've got two of them, 5 pi over 4, and again at 7 pi over 4. Okay, so 5 pi over 4 is here, and that's not in the right place. 7 pi over 4 is here. That is in the right place, but I don't want to think of it in its positive version. I want to think about it in its negative. So if I'm coming over here in the negative direction, that is negative pi over 4. So the inverse sine of negative root 2 over 2 is negative pi over 4. Supposed to put pi there. All right, next, negative pi over 4. How about the inverse tangent of negative 4.3? Well, this is one we can do on our calculator. Radians. Notice here it says radians, so let's make sure our calculator is set to radians. All right, and I want the inverse tangent. First, I'm going to go to my mode. I am in radians. Now I'm going to go to my inverse tangent button. So that's right above tangent. So inverse tangent. And I had negative 4.3. So what do I get? I got negative 1.34. And they said to the nearest hundredth. So I got a 2 there. I'll have negative 1.34. Negative 1.34. Next. All right, find the inverse function. So we're going to find the inverse function. We are given the original domain, so you already know the range of the inverse. You were given the original domain. That's going to be your range. They wanted an interval notation, so now we're going to do it. Negative pi divided by 2, comma, pi divided by 2, and I want brackets because the domain is less than or equal to, so mine is going to include negative pi over 2 and pi over 2. But we got a lot of other things we have to put a little work in to find, but that one at least was given to you right off the bat. All right, so let me go back to my scratch paper. And let's think about this one. All right, we are starting with y equals 2 sine x minus 7. Let's think about this one right here. What is the range of this one? We knew what the domain was, but we don't know what the range here is. Well, let's just graph it. That's a really helpful way. What if I got 2 sine x minus 7, 2 sine x minus 7. And I'm just going to graph it. I'll just zoom standard graph. All right, so I've got the sine function, and I want to know what its range of the original one is before I ever find the inverse. Its range, what y values does it cover? And by the way, it's showing the domain all around here, but the problem restricted the domain just from like here to here. Okay. All right, so what is our range then? Well, what's the lowest point on this guy? Your calculator will calculate that for you real nicely. Second calc minimum. All right, so let's just go to one of these minimum parts here. go a little bit to the left side of that minimum and press enter. Then I'm going to go a little bit to the right side of that minimum. There, I can see myself on the other side. And then I'm going to ask them to calculate it. All right, so the lowest point there is -9. So on this guy, we have a lowest point of -9, and then let's calculate this highest point. Second calc, that'll be a maximum, a local maximum. And left bound, let's just kind of get on the left side of that one. And then press enter. Oh, wait a second. No. I got to calculate it. Second calc maximum. All right, left bound, yep. Then right bound, let's go over a little bit on the right side of that maximum. And then we'll calculate it. There you go. And so it goes up to -5. So mine was going from -9 to -5, and that's the range of the original, from -9 to -5. And then our domain of our original, that's range of original. They gave us a domain of our original of -π/2 to π/2. That was our original domain. Excuse me. So just like that, you already know for your inverse, you know the domain and range just by switching them. Now, but what is the actual inverse function? Well, we have to switch our x and our y and solve. 2 sine y -7. So I'm going to move my 7 over the other side. I've got x plus 7 equals 2 sine y. I'm going to divide both sides by 2. X plus 7 all over 2 equals sine y. And then to get rid of that sine, I'm going to take the inverse sine of both sides. The inverse sine undoes the sine, and that'll leave you with y. And so my new inverse sine function is the inverse sine of x plus 7 all over 2. That'll equal y. I didn't write that very neatly, but so my inverse sine function is x plus 7 divided by 2. All righty. So now let's go back here, what I'm going to put in. All right, I just found that my inverse function is the inverse sine. So sine inverse of x plus 7. I might have to put in a fraction thingy here. X plus 7 up top. The 2 in the bottom. Okay, so that's my inverse function of this original one. The range of the original we just found was -9 to -5. And therefore, the domain of the inverse is going to be -9 to -5. All righty. Number 12. Number 12 at first seems like a doozy. It is not a doozy, but let's work through this one together. All right, the formula D equals 24. 1 minus the inverse cosine tangent I tangent theta all over pi can be used to approximate the number of hours of daylight when the declination of the sun is I degrees at a location 0 degrees north latitude. To use the formula, the inverse cosine of tangent I tangent theta must be expressed in radians. And all of our measurements right now are given to us in degrees. So our first step is to convert 39 degrees, 18 minutes to radians. We're going to have to convert, and they want us to find it at 3 different times of the year. At the summer solstice, so the inclination would be 23.5 degrees. The vernal equinox, that'll be I equals 0 degrees, and that just converts very easily to 0 degrees radians, 0 radians. And then July 4th, the inclination is 22 degrees, 48 minutes. All right. So let's first convert all of our degrees to minutes. And that's a review from last chapter. All right. Starting with Maryland, which is 39 degrees, 18 minutes. All right, well, think about what this means just in decimal form. This is going to be 39 degrees plus 18/60ths of one more degree. So if you do that on your calculator, 39, oops, turn it on, 39, oops, put it out. Clear it off. 39 plus 18 divided by 60. I get 39.3 degrees. Okay, 39.3 degrees. Well, that's still degrees, and I need to switch it to radians. And the switch for radians is to multiply by pi over 180. So I want 39.3 times pi divided by 180. So times pi divided by 180, I get 0.6859 radians. I think I'll just go ahead and I think I'll keep it at 4 decimal places. So I'm going to say 0.6859 radians. At the end, I'm going to round to 2 decimal places, but I'm not quite ready for that yet. So this is the radian. In our formula, this was the theta. This is the location, degree, north latitude, and so it was there. That's the location at Maryland. So this was our theta. And for all 3 of our problems, we're going to have the same theta, 0.6859 radian. For letter A, my my inclination in degrees was 23.5 degrees. Well, I've got to switch that to radians. So I'll want times pi over 180. Put that in on your calculator, 23.5 times pi divided by 180. I get, I'm going to round to 4 decimal places. So I'm going to go 0.4102 for mine, and that's the radians for letter A. Then for letter B, my I equals 0. And so my radians is 0. So I don't have to convert that one. And then for my letter C, my I is 22 degrees, 48 minutes. All right. So this is, switch it to decimal, 22 degrees plus 48/60ths of another degree. And that is going to be, let me double check my math, 22 degrees plus 48/60ths of another degree. All right, so I got 22.8. That's still degrees. So I want to switch it to radians, times pi divided by 180. So 22.8 times pi divided by 180. I'm going to round mine to 4 decimal places again, and I got 0.3979 radians. All right, so now I have converted all of my I's to radians. And now I've got this fairly complicated formula. The hours of daylight is approximated by 24 times 1 minus the inverse cosine of the tangent I times the tangent theta, okay, all over pi. And you know what? You can actually put this all in on your calculator at once, okay? So to do that, you can do 24, and then you can do a big parenthesis, just a parentheses. 1 minus, all right, new parentheses for this whole top. And so that'll be the cosine inverse. That'll automatically put you in a parentheses, tangent of, and that'll automatically put you in a parentheses, close that tangent times tangent. It'll automatically open a new parentheses, put in whatever your theta is. Well, our theta for every one of these is going to be for mine, 0.6859. You probably don't have, I think I was in Maryland. Last one I had Bangor, Maine, but now I'm in Baltimore, Maryland. So my theta is going to be 0.6859 for all of mine. I'm going to close that parentheses to close the entire inverse cosine. And then I'm going to divide that by pi. Okay, so that closed that parentheses. This one closed this parentheses. That one closed that one. And that one closed that one. So I need one, well, that whole thing, then cosine of all of that'll be one thing. Then I need to do that one. I think that should be good. I might need one more by the 24. I think that should be right for my parentheses, but your calculator is super good at telling you that you don't have enough parentheses. All right, so I'm going to do this whole entry and I'm going to do it 3 times. I'm going to do it first with 0.4102, then with 0, and then with 0.3979. All right, so let's see if I can get this whole guy in here. 24 times parentheses 1 minus the parentheses of the inverse cosine of tangent I. My first I is 0.4102. I'm closing that tangent times the next tangent. And that one's going to be 0.6859. I'm closing that tangent. Now I've got to close the entire inverse cosine. One more, divided by pi. And then I'm going to close all that. And it'll tell me if I have too many. No, I had the right number of closing parentheses. So you might want to zoom in a little bit so you could see that a little bit better. All right. So that's my number of hours of daylight for letter A, and they want it at 2 decimal places. So I'm putting in 14.78 for my letter A. For letter B, it's the exact same thing, except I just need to change the 0.4102 to 0. Well, you got this lovely thing, if you don't want to type it all in again, called second entry, and that'll recall your last entry. So I'm going to go second entry, which is above the enter button. And now I just want to change my 0.4102 to 0. Now I'm just take the tangent of 0. I can delete out the 4, the 1, the 0, and the 2, and that's right. Drum roll. 12 hours. And that makes sense that at the vernal equinox, your day is kind of half and half. And then for the last one, my letter C was on July 4th. So I'm going to do second entry again. But this time I'm going to change my, actually, let me do that was my that's my original one. I did second entry twice and it took me back to the one with 0.4102, but now I want to put in 0.3979. All right, enter. And I get 14.68 hours, 14.68 hours. All right, next. Inverse cotangent of root 3. Inverse cotangent of root 3. Cotangent I think it's only sine and tangent that are negative pi over 2 to pi over 2. So I'm pretty sure with cotangent, we are looking between 0 and pi. All right, so we want to come back over here. We're looking for the inverse cotangent of √3. All right, where's my cotangent? Here is my cotangent, looking for positive √3. Well, there it is right there. Pi over 6. Pi over 6. That, it's easier. Next. Inverse secant 2√3 over 3. Inverse secant 2√3 over 3. All right, secant, here we go. Looking for positive 2√3. Look, right there. Pi over 6 again. Inverse secant wins pi over 6. All right, so we're giving you some, what do they call them? Low balls, fast balls, easy balls, slow balls. Is that what they're called? Again here, pi over 6. How about the cosine at the inverse cosine negative √2 over 2? All right, inverse cosine is in between negative pi over 2 and pi over 2. All right, so let's go back over here. Inverse cosine of negative √2 over 2. Inverse, what's it? Inverse sine negative √2 over 2. You got it here at 5 pi over 4, and again at 7 pi over 4. 5 pi over 4 and 7 pi over 4. Well, we don't want that one. We want this one. But we don't want it as 7 pi over 4. We want to count backwards in the negative direction. So that is negative pi over 4. So then the question for me was, well, what is the cosine at negative pi over 4? Well, looky. It's √3 over 2. √3 over 2. Not a terrible problem. All right, last but not least, sine of the inverse tangent of √3. Sine of the inverse tangent of √3. Step 1, what is the inverse tangent of √3? Up, pi over 3. Pi over 3. All right, then what is the sine here at pi over 3? Up, √3 over 2. Or you could do it here. Inverse tangent is pi over, inverse tangent is pi over 3. What's the sine there? √3 over 2. √3 divided by 2. All right, so some softballs there to end it. Let's submit this quiz, see if I led you wrong anywhere. What? I led you wrong here on number 15. What did it do? The cosine of the, I answered √3 over 2. Of course, it's √2 over 2. All right. I must have just been misreading it. And I'm sure you were all yelling at me at the point that I was putting in the wrong thing. All right. So quiz 2, 5.6 through 5.8. You can do it 2 times. You can use the quiz to help you while you do it. And if you run into any problems, you can email me at allsupwh@octech.edu or call me at 268-2516. Remember, your test is just like this. So you should be good on it. All right. Hope you have a great day, and we'll see you later. Bye.